right, section 8.4, the slope of a line. Now, so here we're going to introduce the third option for graphing, and it's probably most common when you get into higher math. So this is a really useful tool to keep in mind. There's three vocabulary words we're going to understand. The first is slope, and the whole process of graphing is going to revolve around what slope is. So in short, slope is the angle of a line. Whatever graph we graph, like if we have this here, this is my graph line, it's the angle of that graph line. So angle of graph line. Okay. Now to represent that, when you hear the word slope, you may think of something like a ski slope. That's kind of what comes to mind when I think of that. And you're most likely going to ski on a mountain. Well, mountain starts with M, and that's actually what we use to represent slope. Slope is represented by the variable M, not S like you might think. M, and it goes back to some way back when the original practices and properties were being founded in regards to slope. But for our purposes, you can kind of hopefully relate it to mountain, think of it that way. Now we have two other terms, rise, which is really the distance up and down, rise. So this is really going to be our change in y values. And I'm going to address a lot of this more as we go, but right now we're just getting the terms written down. And run is going across, so it's going to be our distance across. This is going to be the change in x values. Okay? Now, in this box below, we're going to use this, which says the slope of a line. We're going to use this as like our main reference area. So we're going to put a lot of things in here, and we'll kind of refer to them as we go. What I'd like you to start with is we know that slope now is the same as m. Now, slope is actually given to us by this simple formula, rise divided by run. So the two words we just saw here. Now we can expand that a little more. You might say, well, what is rise? So let's write change in y values. Really, slope is the change in y values divided by the change in x values. And then you could probably even take it one step further. The change in something is usually the difference between two values. If you get paid $10 an hour and then you get a new job that you get paid $15 an hour, the change in your pay, otherwise known as the difference in your pay, is $5. So really we can find this difference is found by subtracting. So really it's just subtracting the y's over subtracting the x's. Okay? So let's kind of keep this in mind. We'll refer to this as we go. And let's apply example 1. They want us to actually find the slope of the following lines. Now I drew these in before I started the recording. They're a little bit crooked. Yeah, they should be straight lines though, so think of them as straight lines. But I also noted a few different points. I'll kind of highlight them. Your graph should be similar. If you have nothing on your graph, I'm going to ask you plot your lines so that they look like this. These are our key points. Now we want to find the slope of this line, meaning we want to find out what angle this line is really at. Now we don't really mean degrees here, like angles, degrees, like you take a protractor out, which looks something like this. You measure and you find out how many degrees this is. Instead, we want to find out an actual number, which is what our slope is. So here's what we're going to do. We see that slope is rise over run. So I'm going to pick 2 points. It does not matter what 2 points we look at. I'll show you that as we go. I'm going to choose this point here and bolden them in, and this point here. Okay, 2 points that cross kind of right where the grid is. Now the first thing it says we have to do is rise. Slope is rise over run. This is kind of the key. If you remember, oopsies, let's not cut right through our notes. If we remember that slope is equal to m, which is equal to rise over run, you'll be set. So the first thing we're going to do is rise. So we're going to go up 1, 2, 3, 4 until we're parallel with our other point. So we know that slope is rise over run. Our rise in this case was 4. Now we have to see how many we have to go over. I go over 2. So my run was 2. Okay, so I simplify. My slope in this case is equal to 2 because 4 divided by 2 is 2. So a couple of things we want to address. Rise has to do with the y-axis. It's what we go up or down. Just like the sun rises, it goes up. So when you rise, you go up. So rise has to go with the y-axis. Run then, if you're going to run, you're usually going to run on like a flat road. You may run on a hill, but for our purposes, we're thinking of like the axes. You're not going to run on something straight up and down. You're going to run across. So this is when we say run. So rise first, go up, and then run. You're either going to go left or right. Okay? Now, let's pick two other points because I told you that you can choose any points and it's going to work. So let's pick this pretty strawberry color. We'll pick the bottommost point that actually crosses at a good grid mark and this point here. So I'm going to go rise first. 1, 2, 3, 4, 5, 6, 7, 8. So in this case, my rise over run, m equals rise over run. My rise value is 8, and my run I have to go over 1, 2, 3, 4. My run is 4, which reduces to just 2. Now some people in class have said things like, well, can't you just pick the two closest ones and you don't have to simplify it all? Yeah, any 2 points that are kind of like adjacent to one another, this would go rise 2 over 1, 2 over 1, 2. It doesn't matter which points you choose, you're going to get the slope as long as you count correctly. And that's the nice thing about linear equations in regards to their slope. Now, one thing that a few people get stuck on is that whenever you plot a point, like if I asked you to plot the point 3, 2, you would go 1, 2, 3 on the x-axis, up 2, and this is your point, 3, 2. So when you plot, you go x and then y. With slope, I'm asking you to do the opposite. It's y, you rise, and then you run. So that's why it's really important to emphasize that slope is rise over run. Because if you remember that, then you're set. Because rise over run, you'll say, oh, rise, I must go up or down. And then run has to be across. Okay? Let's try this next one. Let's find the slope of this line. I'm going to bolden in 3 points that cross right where these like grid lines cross. Because if I were to choose a point like right here, I don't know, that's right in the middle of a square. That looks like negative 1.5, negative 1.55, negative 1.55555, who knows? But here we know we're exact, crossing at the where the lines intersect. Okay, so we're going to do rise over run. I'm going to rise up. I'm going to pick these 2 points here, this one and this one. I'm going to rise 1. So m is equal to rise over run. My rise was 1. And now my run is going to be 1, 2, 3. But you want to add something. In this case, I went to the left, okay? Meaning I'm going towards the negative values, negative 1, negative 2, negative 3. I didn't get into the negative values, but I'm going in that direction. So that means I have to make this a negative 3. Okay, so I went up 1 towards the positive y's, that's positive 1, but then to the left, 3. Okay, so my slope, the negative can go either with the numerator or denominator. I get negative 1/3. Again, if I choose any points, I'm going to get it to work. I can choose this one and this one. I'm going to rise 2. So here I would get 2 as a rise. And then 1, 2, 3, 4, 5, 6, but in the negative direction, so negative 6, which reduces to negative 1/3. Okay, so those are just some practices when you're given the graph, how to go ahead and find slope. Let's take a look. Example 2, it says find the slope of the line through the given points, and they don't give us any graph. So in this case, we have a couple options. We could go ahead and plot these points. We could take a graph and plot 1, 2, and 4, 7 and count up and over. But that's kind of a lot of work, and it's going to use a lot of graph paper too. So what we're going to do instead is we're going to use this formula. And the formula that I'm referring to is the one that we wrote in this like reference box. We said rise over run is really the change in y values divided by the change in x's. So we're going to subtract our y's in the numerator. In the denominator we subtract our x's, and then we simplify. Okay, so here's what I mean by that. First, let's go through and label all of our x's. I'm going to call this x sub 1 and x sub 2. And then I'm going to label my y's. y1, y2. And I put my little numbers down in the bottom so they don't look like exponents. Alright, so m is equal to rise over run. My rise has to do with the y value, so I subtract the y's. 2 minus 7. Okay, subtracted those. Now I have to subtract my run, and the denominator means I subtract the x's, because run you go across. So 1 minus 4. 2 minus 7 is negative 5. 1 minus 4 is negative 3. My negatives cancel, and I get 5/3. There's the slope. You don't need to turn it into a decimal, don't need to turn it into a mixed number. Leave it just like this as long as it's simplified like it is, and you're good.